In the beginning, there was nothing. And then, bang, AEL was born. Astro's Electronics Lab brings you entertaining, sometimes silly videos relating to electronics for your enjoyment. Follow along with his frustrations and antics and maybe learn something in the process.
Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Got some PCBs here to look at today. This came with an order that I got last week. So we're going to take the board, or a board, out of here and have a look at what we've got. Now, this is an LM386 amplifier with adjustable gain. It's pretty much based on a Darren Yates design from Silicon Chip. So there's the little tiny circuit board there. There he is. Very, very small, but very, very useful. Now, I've set this up so it can also use an Electret microphone. So we have a input capacitor here plus a 22k biasing resistor. So the input's over here. So this will apply a slight forward voltage to the positive pin of the microphone. I do have, or at least I did have, it's on the floor over the other side of the room. I have an Electret microphone, one of these little babies. And so you apply a small positive forward voltage to the positive pin of the Electret microphone. The other side goes to ground. And you put a blocking capacitor between the positive pin and the input stage of the amplifier, and you've got a microphone that gets amplified by the IC. I did say this has adjustable gain, and over here we've got a 1k resistor and a 10 microfarad capacitor. Now, if this was just a link wire, not a resistor, you would have the 10 microfarad capacitor across pins 1 and 8, I think it is, from memory. 1 and 8. And that would set the gain to 200. But if you put a resistor in there, you can actually lower that gain down. So at 1k, we're going to be looking at a gain of roughly 50, something like that. But you can put a potentiometer across here and dial it into whatever gain you want. Now, I want to speak about the LM386. There was a person that commented on a previous video I did on one of these little chip amps, and they said they bought a bunch of LM386 ICs and they were all showing different values for the gain. So with the default gain setting of 20, you found that they were very inconsistent. Now, that's due to manufacturing tolerances and component tolerances inside the IC. They used to be built to a pretty high standard back in the 70s, but now not so much. It depends on the batch of ICs and where you got them from too. But when there's no external components to set the gain, like a standard op-amp, how do we know what the actual gain is? Well, we can do a simple calculation. Right, so in order to calculate the gain of an amplifier, we need to know what the output voltage is, RMS, peak to peak, doesn't really matter, and what the input voltage going into the circuit is, peak to peak or RMS. Now, you need to use one of those figures each. So if you're going to take the peak to peak value of the output, you must use the peak to peak value of the input, or else the calculation will be wrong. So say an amplifier, the LM386, produced around about 4.5 volt RMS at its output, and the input sensitivity or input voltage is 250 millivolts. Well, it's V out divided by Vn, so we divide by voltage in, which is 0.25, and that gives us a voltage gain of roughly 18. So that's how you can calculate the gain of an amplifier when you don't know what the actual gain is because there's no external components to say so. That's what I'm going to be doing, is I'm going to be assembling this today in time lapse, just for something to do. And then we'll go about testing it. So to test it, I might actually leave the 22K off and just pump a signal in. I'll have to bypass the pot unless I can buy one today, which I won't be able to do till later. And this will be available on PCB Way as a shared project if you want to buy the PCB and build it up yourself. Either for use for microphone or for just a normal line-in signal. So yeah, I'll have a look around to see what components I've got, and we'll assemble it and see how it works. Okay, so about 10 minutes later, I've got it assembled, apart from the pot. I might go outside and look in my circuit board graveyard, as I call it, see if I've actually got a 9mm PCB mount pot of some description. But yeah, this is almost ready for testing. I'm just going to pop an IC in, and the 22K is not installed yet because I'm not going to be putting the microphones on the input straight away anyway. But yeah, I'll just go out to the graveyard and see if I've got like a pot of some description I can stick there. Unfortunately, no I don't. But I do have this 100K multi-turn 25 turn pot, which I can install temporarily. The actual pitch is the same. It's been used multiple times, multiple different things, and it'll work just to test the circuit. So I'm going to pop him in, and I'm going to solder him in, and I'll trim the leaves off as well. I mean, this pot I've had knocking about for a while, so it doesn't matter, I can use this. It's just going to be a little bit more difficult setting the volume because, well, it's a 25 turn pot, so it'll take a while for the signal to start to increase. So there we go, we got the pot in, and I've put it in so that when you turn it clockwise the volume goes up, and anti-clockwise it goes down, etc. So now I need to find an LM386, which I believe I've got right here. One, they're all stuck together. There we go. One LM386. Okay, make sure I put this one in the right way. That looks like it's been on a board before. I think it's been on a breadboard because the pins are already like fashioned to fit in the correct way, like in properly. Right, there we go. The LM386 is in, so all I have to do is just see where this is set. This pot feels all loose anyway, so it's no real great loss. So I need to hook up an input, a power supply source of around 9 to 12 volts, and the speaker output. So let me get set up with some test equipment and we'll have a look at the output. Alright, I've got the power supply hooked up to the circuit, the oscilloscope, to the output, so the output's unloaded currently, so there's about a megaohm of impedance there, but this is only just to do an initial test. So it's going into the scope, so I'll turn the power on and I'll touch my finger to the input terminal. As we can see, it's jumping around. So now I need to do two things. One is connect the oscillator to the input and ground, which might be just a little bit awkward without things shorting to each other. Okay, cool. And I'm going to apply a 1 kilohertz signal. We have an output, so I'm going to adjust this pot. I don't even know where it's set to. I mean, as I'm rotating it, I think that's maximum output. So I might have to change my voltage per division so I can see what I'm doing. Let's turn the pot, if I can get my screwdriver in there. Signal's decreasing, rotate it the other way. And that's its maximum. So yeah, we're only getting like a volt RMS out at the moment, but that's to be expected. I haven't actually got the oscillators turned up enough either. That might be an issue, so let me get this, there we go, that's a bit better, into clipping, and then I can back off my potentiometer until the clipping goes away. There we go. So it is working as an amplifier, which technically it should out the gate. So now I'm going to load the output with my dummy load, and then we're going to take a power output measurement. It should be around about the 500 milliwatt mark. Got the load hooked up, 8 ohms. Got to be careful with this positively because it's right close to the ground connection and the positive supply rail on the board. So the propensity for it to short is pretty high. So we turn the supply on. Nothing unusual. And we've got an output, but it's clipping, so I'm going to turn down the pot until the clipping goes away. And there we go, about there. So yeah, we're getting 3.12 volt RMS out, which according to this is 1.21 watts. That can't be right. I mean, the chip's getting warm. Huh. 3.21 and increasing. Why is that increasing? The voltage RMS is going up. Yeah, about 3.12. So I'm going to just check my math is correct. Apparently it is 1.2 watts. I am actually confused and surprised at the same time, because I've never had an LM386 ever produce 1.2 watts into 8 ohms, and that's getting quite hot, so I better turn that down. That is odd. That's at 12.2 volts. I would have, that's cooling down now, nice. I would have expected like only about 600 milliwatts at the most. So, it is possible that that commenter on the other video may be right, that they are producing different gains and apparently different output powers. So what I can do is I can swap this LM386 IC out for another one, do the test again, and see if there's any different results. Okay, I got another LM386, just a random one installed. About the same. That is interesting. I have never seen in a long time an LM386 producing more than 1 watt into 8 ohms, ever. I mean, it could be because of the added 10 microfarad capacitor between pin 7 and ground, the bypass capacitor. Maybe, I don't know. It is kind of odd that we are getting 1.2 watts into 8 ohms. It doesn't make sense to me. But okay, I'm not going to complain at that. I probably should hook it up to a speaker instead, and then I might install the 22k resistor and hook up the Electret microphone to it. So let me just get that all set up. Okay, the speaker's set up. I've rotated the 100k pot roughly to halfway, somewhere there, so it's not blasting out into the speaker. And it sounds okay. So what I'll do is I'll change the tone to 200 Hertz will do. I mean, it does sound alright, but then again, it sounds, this oscillator always sounds weird into a speaker. Or it could be the speaker itself might be damaged too, I don't know. But no, it's amplifying into a speaker alright. So I'll hook in the 22k resistor and hook up the Electret microphone to the input, and we'll, you know, I'm going to kill that, and we're going to basically create a megaphone. Why not? Alrighty, the 22k resistor is in and the Electret microphone is connected to the input. Now there will be DC at this input pin now, so you can't connect up a normal line source or anything, because you'll be sending DC back down to the device it's connected to. So keep that in mind. Now the gain might be a bit too high. This may or may not feed back. No, it didn't feed back. Testing 1 2 1 2 3 4 1 2 3 4. Testing 1 2 3 4. Nice. We've got amplification. And if we used, I've just turned the volume up a lot, and if we used like a horn speaker on the output of this, it would be probably sound a bit louder and more tinny anyway, but we've just basically created a megaphone. Isn't that nice? Yay! Alright, so we know that that works with an Electret microphone, which was the whole entire point of me building this in the first place. Turn that off. So what I'm going to do now is, there's not much more else to talk about. I'm going to finish off this video by talking about the schematic, and there'll be a link in the description for the project on PCB Way. I will get the correct pot for this sometime this week and change it. But for now, that was just for testing purposes. It works fine. So yeah, and I might revisit this amplifier project a little later in the year. And maybe I'll make a bullhorn, as they're called in America, or a megaphone, basically. Just for, you know, shits and giggles. But anyway, let's have a look at the schematic and then we'll end the video. Alright, and here's the schematic, which I realised I hadn't even drawn up yet, so I've just quickly gone ahead and drawn it. And the annoying part about KiCad is some of these, you know, symbols are really drawn awkwardly, so it makes, you know, placing components and connecting them up look a bit wanky. I mean, I could go and create my own component for it, but yeah, what's the point? This is the circuit. We've got R1 here, which is the 22k resistor, which is marked with a star for optional for Electret mic. You would not include this component if you were just using a normal signal input here.
the DC is blocked from the variable resistor here by this 100 nanofarad capacitor C1, which goes into the non-inverting input of U1, which is pin 3. Pin 2 is grounded as per the data sheet, so is pin 4. Across pins 1 and 8, we've got R2 and C4, a 1K and a 10 microfarad. That gives us roughly a gain of 50. Pin 7 is bypassed by this 10 microfarad capacitor C3 to ground, and this just bypasses the supply lines and stops the IC from oscillating and howling and all that sort of wonderful stuff when driving at higher gains. Speaking of gains, if you've modified the value of R2 here, you can get various different gains. Just use the calculation for the output voltage divided by the input voltage to work out what your gain is set to after you play with the resistor value. It doesn't really matter what value this capacitor is. I've found during testing that 4.7 microfarad and no resistor, so i.e. a short circuit, will still give a gain of 200. So the value of the capacitor is not really that important. We're now then going into this 100 nanofarad capacitor C5 and R3 10 ohm to ground, forming a Zobel network. And the output will be around about half the supply voltage. So we're blocking that DC with C5, a 220 microfarad capacitor, which goes to the positive speaker terminal at its negative. Negative speaker terminal and ground are connected together, obviously. Plus 9 12 volts coming in here, which goes to pin 6. And C2 220 microfarad here is just filtering the supply line and is actually mounted close to the IC per the data sheet. So yeah, it's a simple circuit. There's not much to talk about, and that's how it works. So I will upload this project to PCBWay, and there'll be a link in the description if you want to buy it and build it. I made it as versatile as possible, as versatile as it can be. But anyway, I'm going to end this video here, and if you enjoyed it, please remember to go down below, like, comment, subscribe if you haven't done so already. And this is the Astro 30 saying, as always, have a great day. Thanks for watching.